welcome to another video. In this problem we're going to be working on restore the array from adjacent pairs. And in this problem you have an integer array nums that consists of n unique elements, but you have forgotten it. However, you do remember every pair of adjacent elements. So you're given a 2D integer array of adjacent pairs where you have every single adjacent pair in the array, and you are asked to rebuild the array from these pairs. So basically they're saying that 1 is next to 2, 3 is next to 4, and 3 is next to 2. So you have every single pair. So like in this array, we can even make it a little bit bigger. So the pairs would be 1 and 2, 2 and 3, and 3 and 4, and that's what we have. And they can be in any order, so you don't really know which one comes first. So if 1 and 2 are pairs, you can write it as 2 and 1 or 1 and 2. They don't really tell you which one. It can be either one, right? So that's what they write. And essentially for this, if 1 and 2 are pairs, 3 and 4 are pairs, and 3 and 2 are pairs, that means the array has to be either 1, 2, 3, 4. This is valid. And also, this is valid. So either one of these is fine, essentially. And let's go to the next one. So 4 and negative 2 are pairs, 1 and 4 and negative 3 and 1. So kind of the same thing, 4 and negative 2 are pairs, 1 and 4 and negative 3 and 1. And finally, you have this one here, where these two are pairs, so you can write it this way or the other way. So essentially, for every single array, if you have some array like this, notice that whatever the array is, the reverse is also valid. Because if you write the array in reverse order, like this, 5, 4, 3, 2, 1, actually, it's a little bigger. There we go. So if we write 5, 4, 3, 2, 1, this is also valid because the pairs are the same, right? 5 and 4 are pairs, 4 and 3 are pairs, 3 and 2 are pairs, and 2 and 1 are pairs. So now, given some list of pairs, how do we actually make the array? So let's say we have this array. We don't know that this is the array. We're going to write down all of our pairs, and then we're going to try to figure out, like, how do we actually build it? So let's say we have, and we can even have it in the right order. It doesn't really matter too much because we're not necessarily going to have it in the right order. But let's say we don't have it in the right order. So let's say so these are all the pairs. Let's say we write them in some order. So let's say maybe 3 and 4 are pairs. And then we can write like 3 and 2 are pairs, right? Because they can write in any order they want. And then maybe 5 and 4 are pairs. And 2 and 1 are pairs. So let's say you're given this list of pairs, and how do we actually make the array? So first of all, what you can notice is 2 of the numbers are only going to have one pair, right? The end over here and the end over here. Because they don't have, like this 5 doesn't have a right side pair, and this 1 doesn't have a left side pair. So you can see 2 of the numbers are only going to appear once. So we can basically think of this as a graph. And so let's actually draw this out as edges. So let's do that. So let's say we have 4 and 3. So we'll first of all, let's write down all of our stuff. And let's, so let's say we have 4, we have 3. So 3 and 4 have an edge. We have 2, we have 1, and we have 5. Now I just drew this like this because it's going to be easier to visualize, but obviously you can have whatever. So for 3 and 4, we make an edge. For 3 and 2, we make an edge. For 5 and 4, we make an edge. And for 2 and 1, we make an edge. So you can basically create a undirected graph of all of your edges, right? So you would just store, and the way you would store it is for every single node, like 5, you would store all of the edges in a list. So you would have like a list of 4, and then for 4, you would have like, let's actually make this, I think this is big, okay. So for 4, you would have like 3 and 5, and then for 3, we would have 2 and 4, right? The order doesn't matter. So we'd basically store it like this, 1 and 3, and finally for 1, we would have 2, right? So you could just go through your edges, you make like a normal adjacency list, like a graph, right? That part, pretty straightforward how to do, just normal graph problem. So that's how we do that. Now, how do we actually use this information to figure out how to make our result? So like I said, notice we have 2 edges here that only have, or 2 nodes that only have one edge. And so these 2 nodes have to be the start and end. So we're gonna make this graph, right? We're gonna go through all of the edges. We're gonna make this adjacency list, and we're gonna find the two nodes that only have one edge, right? So we're gonna, in this case, our two nodes are gonna be 5 and 1, and we're basically gonna just do like a traversal from one of them until we hit the other one. So we're just gonna say like, okay, let's just start at 5 maybe, and we're just going to have some kind of cur that's going to be 5. And what we're going to maintain, there's a few ways to do this. You can either have a visited set, or we're just going to keep track of the previous node we were at. So for example, just to show this in this graph picture, we're going to be at 5. The previous node is going to be start off being null, and this is kind of like a linked list traversal, but not exactly, right? So essentially what's going to happen is we're going to say, okay, we're going to start at 5, and then from 5, we're going to go to any child that is not a previous child. So we can go to, and by the way, once we are at a node, we're also going to add it to our list, right? So let's say we start at 5, we can pick either one of these two. It doesn't matter which one. So we start at 5, we add it in, and then we will traverse to any node that's not, maybe the previous we will just mark with this color. So previous right now is none, and current is 5. So we can go to 4 because 4 is in our children. So we're going to update cur to be 4. And then our previous node is now going to be 5, right? The node that we came from. And we're just going to keep doing this until we get to the very last node. And once we get to the very last node, we know we're at the end. So we're going to say, okay, at 4, we can go to any child that's not previous. So from 4, we have 3 and 5. So we can only go to 3. So we're going to first write in the node that we were at. So we'll write in the 4. And then we will traverse to 3, and we will mark the previous to be 4. Now, if this is confusing, you can just use a visited set, and you can do the same exact thing, right? Anytime you traverse, mark your node as visited, and only go to children. Basically, one of your two children will always be in visited, and the other one won't be. So if that's confusing, you can use that as well. So for 3, we are going to write in 3, and then we're going to check in the children of 3. So we have 2 and 4. 4 is previous, so we're going to go to 2. And then we will update previous to be 3. Then we're going to write in 2. Let's actually write it in the right color. So we're going to write in 2, and then we are going to traverse to 1 because we can't go to 3 because 3 is previous. Now we will update our previous when we traverse to be 2. And then finally, we have our end condition. So we're going to pick one of these to be the start node, and we'll just have a while loop saying like while our current node isn't the other one. And so now we have the break condition where we are at the other one. So now that we're at the break condition, we just exit out our loop, and finally we add our end node to the end. Right, so you have a start node, that's your current node, and then you keep traversing until you hit your end node. And that's pretty much it. So all you need to do is make an adjacency list, find the two nodes with one child, those have to be your start and end, and then traverse either way, and you just either keep track of a visited set or a previous node to make sure you don't go backwards, right? So you want to keep making sure you only go forward. And yeah, that's pretty much it, and that's how you do this problem. So now we can code it up. So we are going to make this like graph of edges or whatever, so we'll call it graph, and it's going to be a default dict. Default dict is pretty convenient for graph because then you don't have to check if things are in there. You could use get method as well, but I like default dict. So we're going to say for start and end in these edges, so this adjacent pairs, otherwise known as edges. For start and end in them, let's just do, so for a graph that doesn't have a direction, right? I'm losing my words all of a sudden. For a non-directed graph, undirected graph, you have to add the edge to both, right? So for start and end, you have to add a path from start to end and from end to start. So we'll say graph start dot append end and graph end dot append start. Okay. Now what we are going to do is we are going to get our, like once we have our graph, we're going to find our two nodes that could be the start or the end. And I'm going to call one of them cur, as in like the starting node we're going to start at, and then the end node. And we're actually going to do a dictionary comprehension. I was actually asked to do, I guess, no, it's kind of like a, yeah, I guess it's kind of like a list comprehension and dictionary comprehension. I guess it is a list comprehension technically, but kind of cool. I was actually asked to do this on an interview, and I didn't know how to do it. So I actually was asked how to do a list comprehension in an interview too, and I was so nervous that I didn't know how to do that one either. So now I've been going overboard with these comprehensions to make up for it. So what we're going to have is we're going to have a key for, and then basically we're going to iterate through the items in the graph. So we're going to say key for key value, right? This will be the node in, maybe we can even have a better name like node, and then node, maybe this can be called like children or something, in graph.items. So graph.items will be a list of key value pairs in the dictionary if the length of the value, I guess in this case it's children, is 1. So meaning, to kind of explain this essentially, so we're going to have our graph kind of like we have here in this picture, and we're saying let's take any key whose list of children is only 1 item. And so there should only be 2 nodes here. So that's how we do this. Graph.items is going to be a list of key value pairs, and we say, okay, if the value is 2, that means the length, or if the length of the values is 1, sorry, then we're going to add that node into these 2 nodes, basically. So what's going to happen here is this is really going to be a list of 2 nodes. So this will be a list of like 2 nodes, like 1, 2, and then we are basically destructuring it into, say, okay, the first one's going to be the current node, and the second one will be the end node. So we're saving some I guess code there. Okay, so now we have our 2 nodes that are the start and the end, and we're just going to start from current and go to the end. And I think this kind of stuff is kind of cool in Python. You might as well try to write a little bit fancier code instead of using like really basic stuff. So I think doing like list and dictionary comprehensions and all these things is good practice to learn. Okay, so we're going to have our result array, and we're going to have a previous, and we'll just make that none. You could use a visited set as well. And essentially, so our cur is going to be our starting node, and we're going to keep going until cur is our end node. So we'll say while cur does not equal end, res.append cur, and then we're going to have 2 numbers in here, right? So we'll say for num in graph cur, there's going to be always 2 numbers. So if num does not equal previous, then that's the one we want. So we'll say previous cur equals cur num, right? So we update cur to be the new number that we found, the new node we're going to, and then previous will be the old cur. And we can break here because essentially if we found it, it doesn't really matter. This is only going to be a for loop of 2 items, but whatever. Okay. And so once we go through this loop, then we added our start node, which is cur, and then all the rest of our nodes, and now we are on the end node. So now we need to add the end node. So we'll say res.append end and return res. And we can try that now. And there you go. And you can see it's pretty efficient, but more importantly, we have fancy list comprehension. Okay, so let's talk through the time and space complexity for this one. So essentially, we're going to be going through all of these adjacent pairs, and we are going to be adding them to the graph. So that's going to be O of n, where n is length of adjacent pairs, right? And as far as this part, we're going to be traversing our graph one more time, so that's going to be O of n as well. And then we are going to be traversing our graph from node to node, and this is also going to be O of n. So we have like O of n, O of n, O of n. So this is O of n, where n is the number of adjacent pairs or the length of the list. Adjacent pairs is going to be the length of the list minus 1, so they're basically the same. And for the space, we're going to have n unique nodes, and then every single node will have 2 edges. So basically the space of the graph is O of n, because we'll have n keys, and every key will have 2 edges, or 1. And then this is a constant, and we don't count the result, and previous is constant as well. So the thing that really we need to have is the graph. And we can't really avoid this. We need to have a graph or like a visited set or something that's basically going to be O of n. And yeah, it's going to be all for this problem, so not too bad as long as you realize like it's a graph and how to figure out what edge to start from. Also to realize that you can start from either end and the connections are going to be basically the same. It doesn't really matter where you start from. The list or the reverse list will both work. So that's going to be all for this one, and please like it if you like it, and please subscribe to the channel. Helps grow it a lot, and I think we're at like 550 subs, so thanks for that. And I'll see you in the next video. So thanks for watching.